Let's solve another example that is very similar to the previous one, especially the part B of a previous example. A person is standing erect and holds a 10-kilogram box at elbow height at a distance of 50 centimeters in front of the lumbar spine. To maintain postural stability, the back extensor muscles need to exert a force to balance the system. Now, the mass of the upper body is 40 kilograms. Since the person is standing erect, it is assumed that the center of gravity of the upper body is directly above the fulcrum, that is, the spine. Assume the back muscles have a lever arm of what is the total compressive force acting on the spine. Assume G to be 10 meters per second squares. So quite similar example. This weight is 10 kilograms mass actually, so weight will become 100 newtons, and this lever arm is 50 centimeters. So that is your inter-vertebral disc actually. And the mass of upper body is 40 kilograms, so the weight will become 400 newtons. And somewhere over here, the force of the muscles is acting, and this distance is again this small distance is 5 centimeters, and there is a force C that actually we are interested to find, that is this force. So this is what we are given. So we call this load to be L, and this was W, this was small l, this was small m, and so that we have the same notation. So we had this simple equation. So sum of the clockwise torques is equal to sum of counterclockwise torques. So the muscle force have a torque of 5. The load is 10 kilograms, so that turns out to be 100 newtons into 50. So this 100 newtons into this 50 centimeters plus 40 kilograms was the weight of upper body into 10, 400 newtons into 0, because we are assuming that the weight of the upper body is just acting through the center of the backbone. So M turns out to be 1000 newtons. So I recommend that you solve along with me. So that force M, the resistive force by these extensor muscles of the back, turns out to be 1000 newtons. Now we are interested to find this compressive force C, this one. So all other three forces, this 100 Newton and this M and the weight, are acting downwards. So C will be equal to sum of these three forces. So the load is 100 newtons, the weight of our body is 400 newtons, the M was just found to be 1000. So the C is 1500. So the back muscle force of 1000 Newton needed to balance the load is 10 times greater than the force exerted by the load itself, that was 100 Newton. So there was 100 Newton that was acting downwards. And this force to balance the torque of this 100 Newton is about 10 times greater. So that is 1000 newtons. So the reason is that the load is held at a distance from the body that is 50 centimeters from the spine. So the back muscles are at a mechanical disadvantage of 10 to 1 because their lever arm is only 5 centimeters. So we know that this distance was just 5 centimeters and this distance was 50 centimeters. So this distance of 5 centimeters cannot be changed. So further the weight is from the body, the greater will be the M. And in fact, greater is the load itself, greater will be the M. So now let's assume that we reduce this lever arm of 50 centimeters and we make it half. So let's suppose we make it 25 centimeters. So this M will turn out to be how much? This was, so that will turn out to be half, right? So that force will reduce to 500 newtons because we have divided by 2. What about this C? So that will become 100 plus 400 plus 500. So that will turn to be 1000. So there is a reduction of 50% in the muscle force that has reduced from 1000 newtons to 500 newtons. And similarly, this compressive force has reduced from 1500 newtons to this is 1000, 1500 newtons to 1000 newtons. So there is about 50% reduction in the extensor muscle force, and there is about 66% reduction in this compressive force by just reducing the moment arm of load held in front of the body to half. So the mechanical disadvantage has reduced from 10:1 to 5:1. So that is actually in our control. We can easily adjust this lever arm, and the closer the weight is to the body, the better it is. And by just reducing that lever arm to half, different forces that are developed by the muscles or are applying to the backbone have reduced significantly. I hope this question is clear.